Hello guys, now this is the first video related to river water problem and application of a vector analysis. Okay, now this type of a technique you can use if a wind is moving with a high speed, a bicycle or a motorcycle is moving, and an aeroplane or any airplane is moving in space, wind is blowing in sky. So you can use this type of a formula. So this is one type of a model to solve this type of techniques. Just to imagine, in the name of river and boats, we should solve this technique. Now this is your direction of motion of the river. Imagine river moves from left to right. This is your upstream and this is your downstream. Velocity of river is u, and that is you choose two spots in the river. River is moving with uniform velocity u throughout the motion. You just assume. Okay. Now a person, a swimmer or a boat or a launch, it is moving with velocity, suppose v, from point A to point B within river. Okay, suppose this distance is, you take d is the distance between the A and B. D is the distance between A and B. Therefore, if the boat moves along this direction of velocity and direction of water remains the same. Angle between the two vectors is 0 degree. Therefore, the resultant velocity must be equal to, that is v plus u. This is the resultant velocity along AB. Therefore, if you take what is the time taken along downstream, that is T1. This arrow is downstream. Water is supporting the motion. The formula is T equal to S divided by V plus U. This is the formula. Okay. Then if the boat reaches here, again he wants to return towards his destination, original place, with the same speed. Distance is the same. Therefore, during the return journey, that is the resultant velocity is V minus U. That means velocity of boat must be larger than that of the velocity of water. Otherwise, it is not possible to cover BA. So the second formula you take T upstream, that equal to T2, that equal to distance divided by resultant velocity. Okay, distance divided by resultant velocity. Then if you consider a person start from A to B, a velocity moves from A to B, a swimmer moves from A to B with velocity v, then it returns. If it returns, the total t, what we call round off, that means this is T1 plus T2. You can take d by v plus u plus d divided by v minus u separately, or you can take, that is a t round, that equal to 2vd divided by v square minus u square. That means if you solve these two, then ultimately you will get this formula. But question is it possible to remember this formula directly? If possible, you write. It will avoid your time. It will consume, it will save your time. If not, then you can use this method for 100% correctness. Okay. Now these are the fundamental formulas. With the help of this formula, let us solve 2 to 3 problems technically. Okay. Now let us take the total time t. Round up is, you take time of downstream plus time of upstream, or you can use direct formula with the help of this. Now let us solve 2 problems. Now what is distance between A and B, that is given 10 km. Downstream from A to B motion, time taken is 2 hours. from upstream B to A, water is opposing, therefore it requires more time, that is 5 hours. So by taking these three data, how can you find out the values of V and U? Okay, how can you find out? Just to imagine T1 equal to D into V by V plus U. So therefore what is D? I am taking D is 10. 10 is V plus U into T1. Okay, that is V plus U into T1. T1 means that is 2 hours. I am taking 2 is this side. Should say first V plus 1 U left. D is 10 divided by 2. This is one equation. Then you take T2 is 5 hours. Similarly V minus U, that equal to 10 divided by 5. This is your 2 hours. Sorry, equation 2. Now if you add these two, you will get 2V. This is 2, this is 5, this is 2. 5 plus 2, 7. If you add U cancels, then find out the value of V. Then if you subtract U, V cancels, find out the value of U. Okay, and after solving, you will get V equal to 3.5 kilometer per hour and U equal to 1.5 kilometer per that is per hour. So this is the values. V equal to 3.5 kilometer per hour and this is 1.5 kilometer per hour. So this is your first formula. Okay. Now imagine I am taking V plus U to left direct. 10 by 2 T means 10 is D divided by T1 is 2. In the second case V minus U take, this is D by T. T2 is here, that is 5. Then you solve. Okay. Then come to the second. In the second data, what are given? T1 is 6 hours, T2 is 8 hours. That means time taken from one place to another place along downstream in river is 6 hours, along upstream is 8 hours, and distance is constant, means body moves from A to B, then B to A, D is constant. Speed of river is 4. Find out the velocity of the boat or velocity of the swimmer. Okay, you take this properties, that is, this is the technique. D is constant, same formula. You take dd, that is D equal to V plus U. U means this is 4 into time T1, that is 6. Second case, same D equal to V minus U, that is V minus 4 into time T2, that equal to 8 hours. Okay. So if you use directly this, then you need not take all this. You take this portion, leave D because D is common. Now 6 into V, 6 into V, 8V you take out left, 8 into 4, that is 32, 6 into 4, 24 take to left. Now this is 2V, okay, this is minus 2V, this is minus 56, therefore V is 28 kilometer per hour. So this is your answer. Mark, this is the equation. If you frame this equation, it is possible to solve the problem orally. Okay. Now let us solve another problem. If a boat moves to and fro 8 kilometers each and it takes 2 hours in still water. If it takes 2 hours in still water, then velocity of boat is 2 times, that is D, 2 times D divided by T. This is 2 into 8 by 2, that equal to 8 kilometer per hour. Indirectly, speed of boat or speed of swimmer is given. Then if you take U equal to 4 kilometer per hour, U equal to 4 kilometer per hour, then that is find out the total time in the round trip. Total time is D is 8 divided by 8 minus 4 plus 8 divided, this is first one is plus, second one is minus. 8 by 8 plus 4 plus 8 by 8 minus 4, you take out 8 common, 1 by 12 plus 1 by 4. If you solve it, you will get the answer is 2 hours 40 minutes. Okay, if you take this formula, same thing, that is t rounds, this is 2 into 8 into 8 divided by 8 square minus 4 square. This is 2 into 8 into 8 by 8 plus 4 is 12, 8 minus 5, 4 is 4. Though you will get again the answer is 2 hour 40 minutes. So this is the application of your third formula. Okay. So similarly, we will now cover the last fundamental formulas, that is, if a boat takes time t1 hour, suppose time t1 hour along downstream, t2 hour along upstream, okay, that is distance travelled is same, means constant, A to B time is t1 hour, B to A time is t2 hour, A to B, B to A distance is same, one is up, another is downstream. Okay. Now if this is the case, if you define another term here, what is t naught? It is time taken by, that is the same boats in same boats to cover same distance in still water. Then you take the formula t naught is t2 and t2 divided by t1 plus t2. So this is your, that is fourth formula. To t1 t2 divided by t1 plus t2 you can take. Okay. For example, this is fourth example. If you take t1 equal to 6 hour, t2 equal to 12 hour, then what is t naught? To t1 t2 divided by t1 plus t2, that is 2 into 6 into 12 divided by 6 plus 12. Okay. To t1 t2 divided by t1 plus t2, 2 into 6 into 12 divided by this. Find out the values. Similarly, if you take, suppose another example that is coming repeatedly in your all entrance exams, I am giving the same data. If t1 equal to 8 hour, that is t2 equal to 12 hour, 8 and 12, number of times it is asked in different entrance questions, that is 8 and 12, perhaps I want to check it. Yes, 8 and hour. Then what is time taken to cover in still water? 2 into 8 into 12 divided by 8 plus 12. This is 20, that is 2 into 8 into 12 to 10, 8, 12, that is 96 by 10, this is 9.6, that is hour. Okay. So these are the sums. Now these are the fundamental formulas of riverboat problem. In next video we will discuss about how to cross the river and while crossing what happens to the velocity, direction and so on. Okay, thanks.